Okay, thank you very much. So, hello everyone. So we've been working with GSQ over the last 3.5 years on this Mary Catherine project, and it's been really good. So thanks GSQ for funding this work. I think we saw a lot of beautiful results yesterday and a lot of nice data sets been done, especially on the geochemistry side. So I was thinking when I was doing this presentation, what should I talk about? Because we presented a few times during this workshop, so kind of trying to avoid repeating what we've already said, which is really difficult. But I thought there are some new kind of results that we obtained. Most of them are part of this project, but some are related to other projects we've been running in parallel and we continue doing. So just, you already know, David showed where Mary Catherine domain is located. Here it's a map with the mineralization. And there are certain deposits, copper gold deposits, there are uranium rare earth, gold only, and there are lead zinc deposits, but they are hosted in different sequences at different ages as well. So it's a spectrum of ages of sequences that host mineralization, except probably the Duga River deposit. There is no giant or really large deposit in the Mary Catherine domain, and so on. So where actually we've been working, if you look on this map, we've been working across almost the entire exposed portion of the Mary Catherine domain. And we've done quite a bit of work as part of this project. And it's difficult to summarize work that it's not mainly geochemical because we've done a lot of field work. So probably combined, we've done about 6 months of field work, looking at rocks during the field and come the bush. So that's difficult to put in a report or summarize, but it comes back in ideas and so on. So probably the main thing that came out of this project is 2 new discoveries, I will call it. It's not deposits, but we kind of identified 2 new orogenic events that affect Mount Ioan. So beside the 1850 and so on Barramundi orogeny and the younger Ioan orogeny, 1600, 1500, we also identified another orogenic event that most likely happened between 1770 to 1800. We didn't give it a name yet. And a second orogenic event, somewhere 1750 to 1710, which we call it the Wonga orogeny. So what I'm going to talk about, so I'm going to just briefly touch on some aspects of stratigraphy, which we didn't really touch before. And also I'm going to focus mainly on Magnoline metabasalt and Argylla formation. And Corella formation, Mount Albert group is mentioned there because they are part of the stratigraphy in the Mary Catherine domain, as well as the so-called basement rocks of the Kalkadun-Leichhardt. But I'm not going to go into Corella because that's something we can talk for an entire day, or Mount Albert group. So we'll just briefly talk about Magnoline and Argylla formation. Then I'm going to briefly talk about some of the interesting results or aspects of the structure and metamorphism in the belt. And I will end up with some, I would say, interesting results in terms of hydrothermal activity. So before going to talk about stratigraphy, you've heard our talks for a while, and it has been for some people controversial in terms they were claiming some things that if you read the literature after 1990, these things were not there in the literature. But actually, if you read all the literature in 1990, you see that these things were already there. So there are very good reports done in 1960s, 1970s, 1980s, extremely good geological reports, very good descriptions, and very good observation. And if you read through these reports, you see that the geologists doing this work, many times they were conflicted in where to put different units and how to interpret. And that's normal because it's very difficult. The rocks are really strongly deformed. They are highly strained. They look similar. So you look at the rock here, and you think it's the same with the rock 50 kilometers away because it looks identical, seems to be relatively similar. Now we had new tools. We have geochronology, we can do it cheap and quickly. So we can kind of separate these units and combine with this. So I put just these 2 quotes here from a 1977 notes associating the geology of the Mary Catherine sheet area. And if you look at this, it says at one moment, uplift and erosion of the western part of the basement. So this refers to the towards western succession, preceded the deposition of the 10,000 meter thick arenaceous and basaltic Haslingden group. So that's not very controversial, know that the basement, the Kalkadun-Leichhardt, has been deformed, metamorphosed prior to this. But the next thing is interesting. Further uplift, folding, and erosion preceded the deposition of the sandstone at the base of Mount Isa Group and Surprise Creek. So what this means that we have a deformation event, some kind of metamorphism that preceded these sequences that are 1670 or younger and so on. And that's what we've been saying. This is exactly like the event that we are talking about, 1750, 1710 or less. So it's been noticed there, it just did not get into the literature very well defined and so on. In the Eastern succession, says the arenaceous and carbonate-rich Mary-Catlin group was deposited unconformably on the basement complex. Okay, and that's the key, because if you look at this basement complex, Magnoline and Argylla formation, they've been included in the basement complex because it's sometimes difficult to separate them. And these rocks have been deformed somewhere 1770 to 1800. Okay, so this, some insights into what we've been finding have already been there in the literature if you look through it for a long time. So probably we didn't find anything new, we just rediscovered things, but anyway, it's good to claim that it's something new. So just this is a compilation of igneous ages that been reported or we dated as intrusive ages. And if you look, start having some peaks on this diagram. And it's obviously the peak that is related to the Chalcedonian event and Barramandi orogeny. But then you start developing slowly a peak of intrusive ages. And this period, 1770 to 1800 roughly. And that's one of these orogenic events that we documented. And we'll talk about them when we talk about Argylla, what that means. Then we have the Wonga burstal type of igneous event where it's a lot of data sets. It doesn't mean it's more important, it's just more data sets, you know, the peak it's higher. Then we have the Sibella event, which I haven't done any work there, we haven't really looked, and it is interpreted as intruding during an extensional event in basin formation. And then we have the Isan orogeny. And what is really interesting with Isan orogeny first, depends how you see it defined. It's a very long period, okay? It's 150 million after, so that's very long for an orogeny. What is also very interesting, the peak Isan orogeny is lacking any granites, okay? And around the world, if you go, it's very common to have during peak deformation metamorphism to have some granites being in place, but here is lacking. Where you have actually the granites coming, it's late during this Isan orogeny. And if you really look, and I will say they are not that late, if you look, these granites, most of them, they are synchronous with active ductile deformation, many parts. They are in place at different parts in the stratigraphy, different levels in the crust, but nevertheless. So these are the two events, and now the paper has been published, and you can find more details about document these events in this paper, so I'm not going to spend time documenting that. So let's go at look at Magnoline and Argylla formation. So this diagram here on the left, it's a simplified time-space stratigraphic column, and what it shows with the rectangle is basically stratigraphic units such as sediments or volcanics, and with this balloon type of shapes, they are intrusive events. And Mary-Catlin domain stratigraphy, it's here where we have this gray area right there. So what consists the Mary-Catlin domain stratigraphy? We have units of the basement, Chalcedon Leica units, then we have Magnoline metabasalt, on top of it we have Argylla formation, then we have the Mary-Catlin group, and further apart, then we have the Mount Albert group. We're going to focus on Magnoline and Argylla here. The main reason is, you look, they are interpreted as time equivalent to the Eastern Creek volcanics, and earlier in the history, they've been interpreted as time equivalent also to the Maraba volcanics on the other side. And that change after some dating showed that the Maraba have to be younger. And this is important because if they are equivalent across a large area, people can start thinking of a large igneous province, a lot of mafic magmatism and so on, and also synchronous with felsic magmatism. So you have this bimodal synchronous type of activity, which can lead to a certain interpretation. So what I'm going to do, I'm going to move that one where it is placed, which actually is here. And a lot of evidence points towards that actually the Magnoline metabasalt has been intruded by granites that are Chalcedon age and so on. And I will show some evidence for that. And I'm going to do something else. I'm going to change Argylla to much, let's say, the extrusive part or the sediment part much thinner, is far less. But actually, I'm going to make it an intrusive event. Because most of the Argylla formation, if you go in the field and you look, it's actually intrusive. So this changes completely the way we look at geology and interpret. All right, so what I'm going to do next, I'm going to take you to just a few locations. One is here, highlighted there, another one and another one, where I show some of these relationships and some of the problems. So the first one is right here, so comes from just west of Duchess. So the Duchess pub is about 7 kilometers. If you climb on a hill, you can get signal, phone signal, and you can communicate with the rest of the world. Otherwise, you're completely isolated. So what do we have there? We have this Marindi Creek granite. We have the Magnoline metabasalt, we have the Argylla formation, and we have the Corella formation. And this is exactly how they've been mapped on the geological survey maps. I didn't change anything, so people can relate to things. And if you look at the way that's been mapped, forget about the ages, okay? Because ages we got recently. You look, this type of boundaries and so on, they look like intrusive into the Corella formation. Definitely this rock. Oh, I apologize for people online, but I'm gonna keep moving. Sorry about that. So you kind of pick up some relation. And if you look on different maps, you see that the bushy pug gneiss has been mapped for a long time as Wonga age or something like that. And that will be okay for, you know, if the age is there to support that. Well, we walked across here and we couldn't see, well, quite a few, we couldn't see the contact. It's mainly flat and you cannot really see. So I cannot say that this contact is intrusive or not. I guess it's based on geophysics. So let's take that as it is. But you can clearly see this bushy pug gneiss. We dated it, and I think GSQ dated. We got similar ages. Intrudes into this, what is mapped as Magnoline metabasalt, and you see interfingering and you see clear intrusive relationships. More, this Marindi Creek granite as well, it's old. And if you really look from aerial photographs, look like a late intrusive, but it really is not. It's deformed and intense deformed in places, in some places less deformed, but nevertheless has enclaves of the Magnoline metabasalt interfingers, and it's also old. So at least at this location, you can say the Magnoline metabasalt should be older than the bushy pug gneiss and the Marindi Creek. Now here is Argylla formation, and if you just go in the field and you look at this, you see, well, this is older than the Marindi Creek, the relationship will tell you, because Marindi Creek seems to intrude into Argylla. But if you look really carefully, you see that actually it's a complex intrusive relationship. The rocks that are mapped as Argylla also intrude into the Marindi Creek. So actually they are very ambiguous relationships. But when you date, you can actually get what is there. You see that the age is 1790 comes of this. The rocks look intrusive, they're highly deformed. But what is really interesting, the same zircons, this age, which is 1570, equivalent to the peak isonorogeny. So we see here an overprint of the peak isonorogeny. And it's very difficult to explain this separate as being an intrusion at 1570 and having xenochrist of 1790. Especially if you look at the overgrown rims, and they look like metamorphic kind of rims.
I'm just trying to see whose dog is barking.
Okay, so that's the situation there. And a little bit further north, we're moving now. And here is again an interesting situation, if you ask me. We have this Bowler Sill hole granite, which intrudes into all of this sequence. Part of it is completely undeformed, part of it is deformed. And then you have a lot of Argylla formation, Magnoline metabasalt. And if you look at the relationship, you walk along, and you see that everywhere where you see this relationship, you see that the Argylla intrudes into the Magnoline. They are clear intrusive relationships. Okay, but what happens, you have right here, you have this bushy park gneiss, mapped as bushy park gneiss. And if you put the two samples, they put on a table and you tell people to tell them apart, you cannot tell them apart. They look the same. But when you date, so I let here all the data for these zircons. So it's from this area here. You actually get an age, if you want to believe that age, because you have to be careful how I interpret something. You say, get an age of 1740. And you think, well, it looks exactly the same. Why is it so much younger? And it looks very different from the 1740 type granites in all aspects. But if you look, what I notice, you have this trend across the Concordia from all the ages, like 1860, all a series of concordant grains, and then you have this disturbance and whatever. So this Discordia actually can fit probably a few lines, depends how you want to play. So I doubt it, so we have to follow up that this is the true age of this granite. So probably it is basement and it is bushy park gneiss. So that's another thing. So one last thing about the different units, which I found interesting. Again, I want to go back to some old literature. First, so this paper I recommend, Blake 1992, which highlighted based on field evidence that the rocks here that are mapped as Argylla formation, these are the same rocks, they do not fit the definition. The relationships and the type of rock structure, they seems to be basement rocks. So we went there and we done drone mapping and all kinds of things and look at different relationship and done in detail and we dated. And fair enough, you did the main intrusive phase. There's lots of complex intrusive relationship. It comes at 1867. So it confirms observation that people have said a long time ago. But this is very important because this occurs to the east of the Wonga belt of the high strength zone, where it shouldn't be there. Okay, and this raises the question, if you look, a lot of what has been mapped as Argylla formation on this side. Look, some literature early on, they say that that cannot be Argylla formation because for different reasons does not fit, but is Argylla formation on the map. And that influences again how you interpret the structures, how you interpret many other things. So the ages for this is straightforward, not much to discuss about. Now, why is this important to get these relationships right on the existing maps? Because when you extrapolate the geology, so here is geology that's been interpreted based on geophysics, you rely on the geology you know and the relationships you know to do that. So if we don't know these relationships right and we don't understand them, we're not going to do very accurate or, let's say, reliable interpretation of geophysics. Now, if we look at this geophysical interpretation of seismics, if Argylla formation is intrusive, you see, it has been interpreted as a unit that extends down. You cannot have it on interpretation something like this drawn. It is an intrusive unit. It looks different. So really has importance, especially for people explore undercover or explore at depth and so on. So we need to take this to get these things right. I don't know if I still have time because I usually talk a lot, but let me know if I run out. So I have to hurry. Okay, so this is the complicated part, so I'll try to make it simple. Okay, so this is the Mary-Kathleen belt, and I just put there the units, which is Magnoline metabasalt, Argylla formation, you have Corella formation, and you have Mount Albert group. And I want to highlight a few things. First, north of the Fountain Range fault, what do you see? You see Magnoline, you see Argylla, you see Corella, and you see Mount Albert group. Mount Albert group disappears south of that. Does not occur anything like that. And you see basement. Another thing I want to highlight different from north as you go south is if you look on this side to the left of this, yeah, is your left of this line, you see that there seems to be an interfinger, or you have Argylla, you have Corella, you have basement, you have Magnoline and so on, which disappears here. And that relation which you see here completely disappears as you go south of that line. And then again, you have different things as you go further south. Okay, so I'm just gonna keep things simple. What this tells me is that we have different structural styles, and we also have different levels of the crust that have been exposed. And more importantly, what I wanna say is that these different levels of the crust, they've not been exposed during one event, they represent multiple events. So some of differences in the level of the crust may be related to 1860. Some of them may be related to 1780, some to 1740, and some of it to much later. So it's not a homogeneous kind of thing. We still have to work that out. Now, if you look at the granite, so this is Mount Godkin granite up there at the north. It's a high-level intrusion, okay? They would say it's undeformed, mostly undeformed, high-level intrusion. Then you go south of this boundary, and you see revenue granite, completely deformed, has two deformation in it. It's pervasively deformed. It's been in place much deeper in the crust when it's been in place. So that's what we see there. You go south, furthermore into south here of the Plum Mountain Fault, and you see the Thick Hill area, you see the granites there are in place, a sheet completely deformed, myelonitic, high grade, even deeper in the crust that's been in place. So you start seeing these levels of different levels of the crust being in place and different levels of erosion. Now, when you try and do some PT conditions, we haven't done a lot in detail, you start to get some interesting stuff. So the maximum values around Mount Godkin area, you get 552 kilobars. Then actually, if you go around the Burstal granite, which is an interesting one because it has, as David said, has some phases that are clearly high level intrusion, but some are much deeper. You get values of up to 650 and 5 kilobars. Then you go further down, you get about 6 kilobars and 650 degrees, and then you go further down, you start getting PT condition up to 8 kilobars, and probably even more. We are following up with some work because there is evidence that the metamorphic condition may have been even higher. So again, pointing towards that, we have different levels exposed at different times. So just this to bring a little bit, we have to look, when we look at this a bit, this is the first attempt a bit different. So you have to look at zones of strain. So what this actually shows is a zone here highlights the zone of the most intense Ioan deformation. As you go into the Merry-Catlin domain, so you have exposed some of the pre-Ioan deformation, and when I mean deformation, I mean folding and some metamorphism. Then you have a zone where it's the highest intensity of strain that you can relate to all the deformation. Then as you move further west, this, again, you start to go into more of type of Ioan deformation. But the relationship between units, which belong to different stratigraphic level, is very complex because you have all these deformation events on top of each other that disturb the stratigraphy, which means you cannot just draw long lines interpreting the stratigraphy. It's highly disturbed. And well, a good example, probably, you know, I don't like the layer cake stratigraphy model. If you look what he had better images than me, Derek presented yesterday. This part here this is Mount Albert group. There is Duga River. If you look on both sides, you have all the sequences that have been previously deformed, metamorphosed, and occurs along these faults, the bounding faults, and seems to be like a localized basin that formed during some kind of event that we didn't figure out what the event was. But it's that type of basins, sub-basins, smaller basins, or isolated basins, we have to think when we think about the Mount Isa itself. When we go outside further apart, things may have changed, but this is an active tectonic zones which gets complexly deformed. How I'm doing with time? I'm up? Okay, so I'm just not gonna go further into things, just gonna highlight that Titanite dating, if you look at the ages, so these are Titanite ages there, that's the main age of that. Actually, you can pick in different Titanite ages, if you are lucky to get good age, you can start picking up the different events. And some of these are actually reflects metamorphic events, but some of them, like this one here at 1530, represent hydrothermal event. I just want to show one last slide. I'm going to skip to this. I think this one is important in terms of hydrothermal stuff. So these are just caprolite data, chlorine, bromine stuff. And if you look at, if you separate them properly based on the text, you know, like go, this is contact metamorphosis, this is metamorphosis, this is can, this is hydrothermal, you start to get certain things, but you notice that there is a window where the copper gets really high. And that window seems to reflect on a certain fluid composition that with scapula, you can track that fluid composition, okay? And if you can track that fluid composition, you can probably track most likely mineralizing fluids. You can find where are these pathways that mineralizing fluids flew up. So sorry for being late. I had only 18 slides, but talking too much. Thank you.